We're gonna discuss the Salesforce developer interview, important questions um, that will be addressed. One of the questions we're gonna discuss is why is Lightning Web Components different from Aura, which comes up often. Lightning Web Components, or LWCs, and Aura are both frameworks provided by Salesforce for building Lightning components. However, they differ in several ways. One, technology. Lightning Web Component is built on modern web standards and uses the web component standards, whereas Aura is built on its own component model. Two, performance. LWCs is faster than Aura due to its smaller bundle size and optimized rendering, which is because LWCs leverage modern browser capabilities such as native Shadow DOM and the Virtual DOM. Three, developer experience, which we need to remember. Lightning Web Components provide a more streamlined and intuitive development experience, making it easier to learn and use compared to Aura. Additionally, LWCs support modern development tools such as VS Code and Jest testing framework. And finally, they are open source. LWC is an open source framework, meaning developer can use it outside of Salesforce platform. On the other hand, Aura's proprietary framework that is only available within the Salesforce ecosystem. Overall, LWC represents a shift towards modern web development practices and provide more performant and streamlined framework for building Lightning components. And moving towards the next question, why is LWCs faster than Aura? So LWC is faster than Aura to several reasons. Small bundle size. LWC has a smaller bundle size than Aura, meaning it takes less time to download and render. This is because LWCs leverage modern web standards and uses small sets of core JavaScript libraries. 2. Optimized rendering. LWCs uses native Shadow DOM and Virtual DOM, which enables more efficient and optimized rendering of components. This is in contrast to Aura, which uses its own rendering engine that can be slower and less optimized. 3. Server-side rendering. LWC supports server-side rendering, which allows components to render on the server-side before being sent to the client. This can reduce the amount of work the client has to do and improve performance. And finally, simplified component models, which in turn, LWC uses simplified component model, which makes it easier to optimize and maintain components. This is because LWC components are more modular and follow more declarative programming style. So overall, these factors make LWC a faster, more performant framework than Aura, which is where Salesforce is shifting into, which is essentially important for building complex and dynamic web application. And moving to the next question, best practices of Apex. So best practice of Apex in Salesforce. 1. Bulkifying the code. Now, when working with the large datasets, it's important to bulkify your code to avoid hitting government limits. This means designing your code to work with sets of records instead of individual records, and using best practices such as SOQL for loops and dynamic SOQL queries. 2. Use try-catch blocks. Always include try-catch blocks in your code to handle exceptions. and prevent unhandled exceptions from being thrown. This is important for maintaining that data integrity and ensuring that your code runs smoothly. 3. Writing efficient queries, avoiding using select all statement, instead only retrieving the fields you need. Also limits the number of records you query to avoid hitting the governor limit. 4. Minimizing the SOQL query and DML statements. Limit the number of SOQL queries and DML statements in your code to avoid the governor limits. Consider using collections to minimize the number of datasets calls needed. 5. Use meaningful variable names. Variable names that are clear and descriptive to make your code easier to read and understand. Avoid using single-letter variable names or critic names that don't convey their purpose. 6. Use comments, which a lot of developers miss out on, to explain the purpose of your code and provide context for other developers who may work on the code in the future. And lastly, test your code thoroughly. Always test your code thoroughly using unit tests and integration tests. This helps ensure that your code is functioning as expected and does not break other parts of the system. And overall, following these best practices can help you write efficient, maintainable, and scalable AWS code that works well within the Salesforce platform. Another question, best practices of trigger. This comes up a lot, including with best practices of Apex. And best practices of trigger in Salesforce is using before triggers whenever possible. Before triggers can modify their field values before they are saved to the database, which can be more efficient than using after triggers, which requires an additional database update. 2. Minimizing the number of triggers per object, preferably to have one trigger per object. Too many triggers on the same object can lead to conflicts and make it difficult to maintain and debug your code. Try to consolidate multiple triggers into single trigger, or use Trigger Framework to manage your triggers. 3. Use static variables to store data. If you need to store data between trigger events, use static variables instead of instance variables to avoid hitting the governor limits. 4. Use query fields or query filters to limit the number of records. Use where clause in your SOQL query to limit the number of records returned and avoid hitting governor limits. Avoid using hard-coded IDs. Instead of using hard-coded records, hard-coded record IDs in your trigger code. Use dynamic reference to avoid errors when record ID changes. 6. Use trigger handle classes. Trigger handle classes can help you manage your triggers more efficiently by separating your code into smaller reusable components. Finally, test your trigger thoroughly. Always test your trigger using unit test integration to ensure that your work is expected and does not conflict with other parts of system. So by following these best practices of trigger in Salesforce, you'll be able to have much more smoother process. Um, Another question that usually comes up says roll-up summary fields. A roll-up summary field is a type of custom field in Salesforce that displays the summarized value of child record on a parent record. It can be used to perform aggregated collections such as sum, count, average, min, max of a specific field on the child records. And some best practices for working with roll-up summary fields are determine the need for a roll-up summary field. Consider whether a roll-up summary field is best solution for use case. Roll-up summary field can be powerful tool for summarizing data, but they also have limitations and may not work for all scenarios. Choose the correct field to summarize. Choosing the correct field on the child object to summarize based on your use case. It's important to select field that has the correct data type and it is relevant to calculation you need to perform. Third, understanding the limitations. Roll-up field or roll-up summary field has some limitations, such as the inability to summarize the data from more than one level of related objects, and the inability to summarize data before on the specific criteria. Consider the impact on performance. Roll-up summary fields can impact the performance of your org, especially if you have large number of records or complex calculations. Be sure to test your roll-up summary field thoroughly to ensure that it does not negatively impact performance. Fifth, test your roll-up summary field. Always test your roll-up summary fields using test data and various scenarios to ensure that it works as expected. Document your roll-up summary field. Document your roll-up summary fields, including information about the calculation it performs, the object involved, and any limitations or performance considerations. And overall, roll-up summary fields can be powerful tool to summarize data in Salesforce, but it is important to understand their limitations and use them wisely. So by following these best practices can help you create efficient and effective roll-up summary field in your org. Now, outbound messaging is a good question that always used to confuse me. But once I got a hang of it, it is a feature in Salesforce that allows you to send messages automatically from Salesforce to an external service. It can be used to integrate Salesforce with external systems such as ERP or supply chain management system. And we'll give you some best practices for working with outbound messaging. Using outbound messaging for real-time integration. And outbound messaging is a real-time integration method that can be used to trigger external systems to take immediate action when data changes in Salesforce. It is not ideal for batch integration or for large volumes of data. 2. Setting up secure communication and outbound messaging. When setting up outbound messaging, it's important to ensure that the communication between Salesforce and external system is secure. You can use HTTPS to encrypt the data that's transmitted between the two systems. 3. Use a retry mechanism. Outbound messaging can be sometimes fail due to network connectivity. or other issues. It's a best practice to implement a retry mechanism in your external system to handle these failures and ensure that the message is delivered. Another thing, monitoring outbound messaging. It's important to monitor outbound messaging to ensure that it's working as expected. You can use Salesforce monitoring tools such as debug logs or even monitoring to monitor outbound messaging and troubleshoot any issues that arise. Document outbound messaging. So documenting your outbound messaging setup, including the external system that it receives the messages, the data that it's being sent, and any error handling or retry mechanism that are in place. Overall, outbound messaging can be a powerful tool for integrating Salesforce with external systems. Following these best practices can help you set up a secure, reliable, and efficient outbound messaging integration. Next question will be call out and outbound messages. What we need to focus is uh, timing. Callouts are initiated from Salesforce when a trigger, button, or other actions occur, while outbound messaging is triggered automatically when a record is created or updated in Salesforce. To the direction. Callouts are used to send data from Salesforce to external system, while the outbound message is used to send data from Salesforce to external systems. Response handling. With callouts, you can receive response from external systems and handle it within the Salesforce, while with outbound messaging, you don't receive response back from external systems. Error handling. With callouts, you can implement error handling and retry mechanism to handle failure requests, while under outbound messagings, Salesforce will automatically retry failed messages for a certain period of time. Implementation. Callouts are implemented using Apex code, while outbound messaging is configured using Salesforce setup interface. So, in general, callouts are more flexible and customizable than outbound messaging, but they require more development effort and expertise to implement, while outbound messaging is a simpler and more automated integration method that can be used for real-time integration scenarios, but it has some limitations in terms of customization and error handling. The choice between callouts and outbound messaging depends on the specific integration requirements and constraints of your project. Moving toward to different project or question, record types. So record type in Salesforce are used to provide different sets of pick list values, page layouts, and business process for different types of records in the object. This allows you to tailor the user experience and data capture to specific use case or business needs. Now, some of the practices for working with record type in Salesforce are planning your record types carefully. Before creating a record type, carefully plan out the different use cases or business needs that they will address. Consider the different sets of pick list values, page layouts, business process that each record type will require. Keep it simple. Avoid creating too many record types, as this can make the data module and your user experience overly complex. Aim to create only as many record types as you need to address the specific use case or a business need. Use a different record types. when possible. When creating record types, consider whether you use the different record types instead of creating a new one. Default record types have the same pick list value, page layout, business processes as master record type, and can save you time and effort in setup. Define validation rules and workflow for each of the record types. When creating a record type, consider the different values or validation rules and workflow that will require for each type. This can help ensure data quality and consistency across from different types of record. Finally, train your users on record types. When introducing a record type to your users, provide training and documentation to help them understand the difference between different types of records, how to set the record correctly, type for each use case. And overall, the record type can be a powerful tool for tailoring the user experience and data captures in Salesforce to specific use case or business need. So by following these best practices, can help you ensure that your record types are well designed, easy to use, and efficient in supporting your business processes. Like planning your records type carefully, keeping it simple, using default record types when possible, defining validation rules and workflow for each of your record types, training your users on record type. Now, another question that we'll have is SOSL and SOQLs within the Salesforce. So, what is the definition of SOQL? Is Salesforce Object Query Language. And the definition of SOSL is Salesforce Object Search Language. So they are two different query languages used in Salesforce to search and retrieve data from Salesforce objects. Now, to simplify or expand a bit more on SOQL is used to retrieve data from a single object or related objects in Salesforce. A single object. It can be used to filter, sort, and group database on the specific criteria. SOQL is similar to SQL and uses a similar syntax, but it is optimized for Salesforce data and has some differences, such as using Salesforce API name instead of the database table names. And when it comes to SOSL, Salesforce Object Search Language, is used to search for records across multiple objects in Salesforce. It is designed to search for specific terms or phrases in multiple objects that can be used to search for records that match a specific criteria. SOSL returns a list of records that match the search term or phrase along with the associated objects. And I'll give you some key differences between SOQL and SOSL. One of the difference is SOQL is used to query data from a single object or related objects, while SOSL is used to search for records across multiple objects. SOQL can retrieve records based on specific criteria, while SOSL searches for records based on search terms or phrases. SOQL supports aggregated functions such as sum and average, while SOSL does not. SOQL supports subqueries, while SOSL does not. So in general, SOQL is best used when you need to retrieve data from a specific object or related objects, while SOSL is best used when you need to search for records across multiple objects. While building queries, it supports to choose the right language based on your specific requirements. and to test your query thoroughly to ensure they return the correct results. And finally, our last question is about query and QueryAll. Now in Salesforce, there are two methods to retrieve data for an object using the API, using query and QueryAll. Now the difference is QueryAll is a standard method used to retrieve subset of records from objects. It returns only those records that the user has access to, based on their permissions and sharing rules. Query is used to retrieve data from standard and custom objects, and it can retrieve up to 50,000 records in a single call. While QueryAll, on the other hand, is an advanced method that can retrieve all records from an object, including delete and archived records. It bypasses the sharing rules and security settings and returns all records, including those that user does not have access to. QueryAll is used to retrieve data from objects like account history, case history, and task priority when you need to retrieve deleted records. And some of the key differences between query and QueryAll are query retrieves a subset of records, while QueryAll retrieves all records, including deleted and archived records. Query respects the sharing rule and security, while QueryAll bypasses them easily. Query is used to retrieve data from the most standard and custom objects, while QueryAll is used to objects that support deleted and archived records. Finally, QueryAll can be slower than consume more resources than query, so it should be used sparingly. And just to sum it up, query should be used for most queries as it returns only the records that the user has access to and is more efficient. QueryAll should be used only when you need to retrieve all records, including deleted archive records, and have the appropriate permissions to do so. And with this, we wrap up the question and answers. You can check out the other videos. Hopefully that will help in your upcoming interviews.